In this video, I'll explain most frequently asked interview question, that is ArrayList versus LinkedList. So both ArrayList and LinkedList implements list interface, and both will allow duplicates and maintains insertion order. So maintains insertion order in the sense, so in how order we are inserting elements, while retrieving also we will get the elements in the same order, and it will allow multiple null values because it implementing list interface. So list interface will allow multiple null values. So that's why ArrayList and LinkedList also will allow multiple null values. So coming to ArrayList internally uses dynamic array. So dynamic array we can refer as a global array also. Like if normally array will be like fixed in size. So if we try to add the one more element, if array is full and if we try to add the one more element, it will create a new array with a new capacity. So by using this formula only, it will create a new array. So coming to retrieval is very fast because arrays will work with the index. So by using index, we can get the data directly. So time complexity for retrieval of 1. And coming to insertion and deletion, time complexity will be often because it is very slow. Because here elements need shifting. Like for example, we have the 100 elements. If we try to insert at the index 2, then remaining 98 elements need shifting. So that's why insertion and deletion will be slow in the array list. Time complexity will be often. And ArrayList uses less memory because it stores only data. So comparing to LinkedList, it will use the less memory only because we don't have any references like a previous node, next node and all. Here we don't have, just we have the data. We will store the data in the memory, so it will take the less memory. And traversal is very fast because elements are stored in the continuous memory location. This is the biggest advantage of ArrayList. So elements will be stored in the continuous memory location. For example, in CPU, element 1 stored in 1001 and element 2 will be in 1002, 3 will be in 1004. So like that, continuous memory locations will be allocated. So that's why traversal is faster. So searching is also very faster. So ArrayList is mainly used when retrieval is frequent, searching is frequent, and iteration is frequent. So in these three conditions, we can use ArrayList. So this is the ArrayList representation. Here we are trying to insert C at D. So now D, E, F 3 needs to be shifting. And coming to LinkedList, LinkedList internally uses doubly linked list. So doubly linked list in the sense it contains it will be like stores the data in the form of nodes, right? So nodes will contain data, previous node address and next node address. That's why we can say it is a doubly linked list. And retrieval is slow because traversal happens node by node. So if you want to retrieve any element, we have to traverse complete linked list. So time complexity will be often. And insertion and deletion, it does not require any element shifting. Like in array list I said, right? So if you want to insert at middle, we have to shift the remaining elements. But in linked list, we does not need any shifting, but still we have to traverse to find the position and insert there. So that's why time complexity will be often. But here shifting is not required, but still we have to traverse to find the particular position. That's why time complexity will be often. And linked list uses more memory. So in array list I said like a linked list, array list uses less memory because it stores only data. But here linked list uses more memory because it stores along with the data, it stores previous reference and next node reference. So that's why it will use more memory. And traversal is slow because the nodes will not use the continuous memory location as the array list uses. So it use the so here nodes will be scattered in the memory, so it won't be like continuous in the memory location. So that's why traversal is slow. So linked list mainly we will use like frequent insertion removal is required. In this case we will use linked list mainly. And here is the image representation for the linked list. So here data will be stored and reference to the next node and previous reference. So everything will be stored as a single node. This is the complete linked list representation. Here we represented null means it indicates there is no any previous element. This is the first node, and null at the last. It represent like there is no any last element. This is the last node it will represent.